Welcome to this lesson on complex numbers. First lesson in Unit 2. What I'd like you to do is grab a calculator. If you need to pause the video, do so. And try to take the square root of these three numbers. Square root of 64, square root of 16, and the square root of negative 36. If you take the square root of 64, you should get 8, or maybe you just know that. The square root of 16 is 4. And when you type in the square root of negative 36, you get an error message because we are unable to take the square root of a negative number until today. We can now take the square root of a negative number and turn it into what's called an imaginary number. Okay? We just need to remember that the square root of negative 1 is equivalent to I, our imaginary number symbol. Okay? So super important. I is equivalent to the square root of negative 1. So to simplify the square root of negative 36 from our example, okay, we can separate that negative 1 out. And we can say this is the square root of positive 36 times the square root of negative 1. Because we know if we take 36 times negative 1, we're back up to negative 36. So we can factor it out. Now I can take the square root of positive 36. That it would be 6. And the square root of negative 1, how we're going to rewrite this is that's equivalent to I. We need to remember that. And so my answer would be written as 6I. Let's try another one. I'm sure you can guess what this one will be. So we have the square root of negative 100. So I'm going to take the square root of 100, multiply it with the square root of negative 1. We're factoring the negative 1 out. The square root of 100 is 10. The square root of negative 1 is I. And there is my answer. Let's take a look. What happens? We get a little more complicated. We have a 2 out front, but don't be alarmed. We're just going to have to multiply in the end after we simplify the square root of negative 36. So we have 2 times the square root of 36 times the square root of negative 1. Reduce that, we get 2 times the square root of 36 is 6. The square root of negative 1 becomes I. And we can multiply these together to make 12I as my final answer. A quick review on reducing square roots that would yield decimals. If you type in the square root of 80, you do not get a whole number. So there's this thing that we can do to reduce this. It's called making a factor tree. So think of two numbers that multiply to get 80. The two I think of that are 10 and 8. You can think of whatever, you will come up with the same numbers as me in the end. So we can reduce 10. Two numbers that multiply to get 10 would be 2 and 5. And two numbers that multiply to get 8, I think of 4 and 2. 2 can't be reduced, 5 can't, 4, we can reduce it down to 2 and 2. And I look for pairs. So I see one pair of 2's that I'm going to pull out. I see a second pair of 2's that I'm going to pull out. So I'm pulling them outside the radical. So what this looks like is we have one set of 2's times a second set of 2's. And underneath, the only number that we're left with is this 5 right here. As soon as I pull out these numbers, that 10 and that 8 go away. So I'm left with 5 underneath. So my final answer would be 4 square root of 5. So the square root of 80 reduces to 4 times the square root of 5. We're going to practice this more in the examples to come. Hopefully you remember doing something like that in your earlier math days. So let's reduce it when we have a negative number here. So don't be alarmed. All we got to do is make this a positive 12 by separating out the square root of negative 1. We know that that's going to be I, and we can wait till the end for that. This 12, let's look at two numbers that multiply to get 12. I think of 4 and 3. And to reduce 4, we can go 2 and 2. So there's my pair of 2's right there that I can pull out front. I'm left with, there's just a 3 underneath the radical, times I. So 2 times the square root of 3i. That would be our answer. Sometimes it gets a little more complicated. Say we have a fraction out front. Well, we're going to wait until the end to compute that. So we're first going to separate this out, make this a positive 75 times the square root of negative 1. Now I can reduce 75 there. Think of two numbers I multiply to get 75. I think of 3 and 25. I got 3/4, I've got 75 cents. Makes it easy for multiplication. That 25 can reduce to 5 and 5. And there is my first and only pair. So I pull the 5 out front. So the first thing I'm going to do, I'm going to bring down that 1/5. We haven't touched it yet. We'll put the 5 right here. Square root, the only number we're left is that 3. So the square root of 75 reduces to 5 square root of 3. And that square root of negative 1 becomes I. Now the last thing we can do is we can multiply 1/5 times 5. That leaves us with just 1. 1/5 times 5 is 1. So my final answer is the square root of 3i. We can use this idea to solve an equation as well. X squared equals negative 81. To solve any equation that has a power of 2 in it, we need to take the square root of both sides. So I'm going to start by taking the square root of x squared, then I'm going to take the square root of negative 81. That cancels, that leaves me with x equals, whenever we have an equal sign and we take the square root of both sides, we need to remember there are two possible answers, a positive and a negative. So this is going to become plus or minus the square root of 81 times the square root of negative 1. I'm just skipping one step to save us some room. We know that the square root of 81 is 9, and the square root of negative 1 is I. So my answer is x equals plus or minus 9i. Let's try this idea again. X squared equals negative 9. Take the square root of both sides. I'm left with x equals plus or minus the square root of 9 times the square root of negative 1. So we're left with plus or minus the square root of 9 is 3. Square root of negative 1 is I. So x equals plus or minus 3i. I've got two examples when there is more than one step to follow. So we have 4x squared plus 16 equals 0. So we're not able to just take the square root right away. We've got to separate these numbers from that x squared first. So I'm going to subtract 16 from both sides to start. Cancels that. We have 4x squared equals negative 16. We've got to separate the 4 by dividing by 4 on both sides. 4's cancel. I'm left with x squared equals Negative 16 divided by 4 is negative 4. Now it's just like our previous examples. Square root both sides. We get x equals plus or minus the square root of positive 4 times the square root of negative 1. So my final answer, square root of 4, we know that that is 2. So we get plus or minus 2, square root of negative 1 is I. Alright, I'm going to show you the second example. Okay, see if you can follow along. 2x squared plus 200 equals 0. We're going to subtract 200 on both sides. We're left with 2x squared equals negative 200. Divide by 2. Divide by 2. X squared equals negative 100. Need to take the square root of both sides. So we have x equals plus or minus the square root of 100 times the square root of negative 1. And I'm left with plus or minus 10i. Alright, I'd like to see, we want to be able to simplify as in number 1 or solve an equation as in number 2 here. So if you want to pause the video, try these on your own to see if you are getting it. I will reveal the answers in a second. So pause the video now. Here's the answer for number 1. You're going to separate this out. Square root of 90 times the square root of negative 1. Make a factor tree. Okay, say 9 times 10. We're left with 3 and 3. There's a pair. I know that 10 is 2 times 5, but that doesn't make a pair. So when I pull the 3 out front, I need to multiply those two to get back up to 10. So I'm left with 3 times the square root of 10 I. Okay, now I'm going to reveal the answer for number 2. This one, you got to subtract 300 on both sides. 3x squared equals negative 300. We're going to divide by 3 on both sides. X squared equals negative 100. And we've actually seen this before, so we know how this should end up. So x equals plus or minus the square root of 100 times the square root of negative 1. X equals plus or minus 10i.